helping educators design more effective teaching strategies. Quantitative research relies on numerical data and statistical methods to analyze relationships, trends, and patterns. It is often used in studies that require objective measurements and structured data collection, such as experiments, surveys, and tests. The primary goal of quantitative data interpretation is to derive meaningful conclusions based on statistical analysis, allowing researchers to test hypotheses and make generalizations about a larger population. By applying statistical techniques, researchers can identify significant differences, correlations, and trends in the data. A key aspect of quantitative data interpretation is the use of descriptive statistics, which summarize data through measures such as mean, median, mode, standard deviation, and percentages. These statistics provide an overview of the dataset and help researchers understand its distribution and variability. Additionally, inferential statistics allow researchers to make predictions beyond the collected data using hypothesis testing, correlation analysis, and regression models. These methods help in determining relationships between variables and assessing their significance in the study. To enhance the clarity of findings, researchers often use comparative analysis to identify differences or similarities between groups. Statistical tests such as t-tests and ANOVA, analysis of variance, are commonly used for this purpose. Moreover, graphical representations such as charts, graphs, and tables play a crucial role in visually presenting data trends and patterns. Another important aspect is evaluating significance and effect size, where researchers determine the impact of variables by assessing p-values and confidence intervals to establish whether results are statistically meaningful. For example, in a study on students' academic performance, a researcher might conduct a t-test to compare the average test scores of students using traditional learning methods versus those using technology-assisted learning. If the statistical analysis reveals a significant difference in performance, the researcher can conclude that the mode of instruction has an impact on students' learning outcomes. Through rigorous quantitative interpretation, researchers ensure that their conclusions are based on empirical evidence, making the findings reliable and applicable to real-world settings. Mixed methods research combines both qualitative and quantitative approaches to provide a more comprehensive understanding of a research problem. It integrates statistical analysis with thematic interpretation to strengthen findings. Key aspects of mixed methods. Data interpretation include the integration of findings, which involves comparing and combining numerical results with qualitative insights. Convergent interpretation, where researchers check if both types of data lead to similar conclusions. Sequential interpretation, which uses qualitative findings to explain quantitative results or vice versa. Data triangulation, validating findings through multiple data sources and methods. And meta-inference, drawing overarching conclusions based on both qualitative and quantitative data. For example, in a study on the effectiveness of a reading intervention, a researcher analyzes test scores to measure improvement and conducts interviews to understand students' experiences with the intervention. The interpretation of data depends on the research approach. Qualitative research seeks to understand experiences, meanings, and themes, while quantitative research focuses on numerical analysis, patterns, and statistical relationships. Mixed methods research integrates both approaches to provide a well-rounded perspective. Interpreting data correctly ensures that research findings are reliable, meaningful, and useful in decision-making, policy development, and further studies.